All right, welcome back. So we're going to talk about the basic theory of linear differential equations. We're jumping around a little bit in the book, but I figure that what's the point of this sort of structure of class if I can't? I think I have ways to improve it. Okay, let's hope. Let's see. Otherwise, I'll just reorder these classes, and you're seeing this out of order of what I intended. Never mind. It's too much time without leaving the house, as I'm sure you can all relate to. Okay, so let's take, or maybe not, maybe y'all are those people that are going out and having parties, spreading the disease so that all of us have to stay inside. Thank you, if you're one of them. So let's say we have a differential equation, nth derivative of y plus p1x, y n minus 1 of x, plus, and then we just keep going all the way down to p sub n of x, y of x, and then we equal some g of x. Okay, now we're also going to need some initial conditions. Now we see this is an nth degree differential equation, so we need n initial conditions. So we'll say y0 of x, or y0 equals y0, all the way down to y sub n minus 1 of 0 equals, we'll call it y sub n minus 1. Okay, we're going to need some conditions. So we're going to say that p1 of x all the way through pn of x and g of x are all continuous on some interval a, b, and actually I made a mistake here. This 0, I should make it as x0 because it's not necessarily 0. Okay, containing x0. Okay, so now this is the condition for us to have a unique solution. So there exists a unique solution. Okay, y of, let's say y of x, satisfying the initial conditions. Furthermore, okay, y of x is of the form c1 y1 of x plus c2 y2 of x plus c sub n y sub n of x. Okay, now these are not the same as these y zeros. Okay, plus some y particular of x. Okay, where? What's going on? The y sub 1 through y sub n those satisfy the homogeneous equation. Okay, the homogeneous equation is, of course, yn of x plus p1 of x, y sub n minus 1 of x, plus p sub n of x, y of x equals 0. Okay, so these satisfy the homogeneous equation, and this y particular allows you to match the right-hand side. Okay, let's just quickly do a couple of examples, trying to understand these points, okay? So first, example, let's take x times x plus 1, y triple prime, minus 3x, y prime, plus y equals 0, with initial conditions, y of negative 1/2 equals 1, y prime of negative 1/2 equals 0, and y double prime of negative 1/2 equals 0. Okay, and the question we're asked, we're not asked to solve this right now, but we're asked to find where does this have a unique solution? On what interval? Okay, so on what interval does this have a unique solution? So the first thing that we're going to do is we're going to actually put it in the right form. So if you look at our form here, above here, notice that we take the first coefficient is 1. Okay, so that means we're going to have to divide this x times x plus 1 throughout. So we're going to write this now as y triple prime minus 3x over x, x plus 1, y prime, plus 1 over x, write that again, x, x plus 1, y equals 0. Okay, same initial conditions. So let me write those or copy those down. Of course, that copied. So let's get that. Okay. So this is the same problem. Okay, but now we can see where it's not continuous. It has problems at x equals 0 and x equals 1. Right? Not problems, but let's say discontinuities. Okay, so we say that our interval of existence is 0, 1. Okay, and now actually we are wrong, not 0, 1. Why not? And actually it's 0, negative 1 for 1. Okay, so interval of existence uniqueness is negative 1, 0. Now, let's pretend we had a slightly different problem. We'll stay with this. Okay, but let's change our initial conditions to be at positive 1/2. Okay, you see the difference, right? So if it's at positive 1/2, this is still a problem at negative 1 and 0, but now our interval of existence uniqueness is going to change. It's actually going to be 0 to infinity. We can extend out to infinity because we don't run into any other problems. The only places we run into problems are at 0 and negative 1. Okay? Likewise, if I would have had let's say my initial conditions were at -1. No, can't do a -1, but -2. Initial conditions at -1 won't make sense, right? Just as initial conditions at 1 won't, or at 0 won't make sense. But at -2, we can have initial conditions that make sense. Our interval of existence here okay, is going to be the interval that contains -2. So that's going to be from -infinity to -1. Okay? All right, so I've changed the problem just 3 different ways, and you can see how the 3 different ways have a different existence properties, right? We have problems at 0. We have problems at -1. Okay. Problem 1, the original, has interval of existence there. Problem 2 has interval of existence there. And problem 3, or the third version, had interval of existence here. Oh, that's not good. Okay, so that one's in yellow. That one's in orange. And that one's in red. Okay, all right, I'll see you in the next video.